And hello for being here, I guess. Welcome to another episode into this hopefully not very long journey into creating maps for areas prioritizations dedicated to amphibians, so we can locate, as I just said, priority areas for conservation and other type of strategies. So in the last episode of this specific series, I went through the code of the projection, because right now we're still in the modeling phase. So it's basically three phases. One is variable selection, and the species selection and variable selection. Then is the modeling of the species that has two steps. Well, technically three, which is the projection, the calibration, projection, and creation of creating the maps. And then the last big step, which is the actual prioritization. So in the past video, I went through the script from BIOMOD, which is the one that I used to model the species. And I more or less explained and I showed that we were going to be modeling distributions for, well, distributions of suitable environment for past, current, and one scenario for future. Right? I went and explained what do technically these functions mean. First, we need to take our data, the variables that are located specifically to our area of interest, because the calibration was in a greater extension. So what we needed to do is to bring the 1 by 1 kilometer variables and then associate it with the calibration information, which is already made for each one of the species, right? And I also indicate that this looks pretty similar to the projection script. Basically, this is the only module that is different, but it's set up almost similar, right? But I went into deep explanation in the other place. So what comes next is, once again, is verify that we were producing actual results and to have a look of what kind of results we were getting, right? We also did this in the calibration section. So here it's basically what we just did, which was taking all the TSS, which is the evaluation, the statistic to evaluate the reliability of the model. And we set them up in a table, right? So that's what we have here. Then we create the whole sequence for a map, yeah, in which what we did is to take the results of the projection and divide them to the TSS, yeah. So for example, we need to consider that the run goes 10 times in total, because it's 10 species. I need to run for each one of the models, which were 8. And we need to remember that the process of the projection or the modeling happened 10 times, right? So this is why we have this type of repetitions, because here I'm constructing a table, which is a table with the values of the projection of each one of the models. In the end, hold on just a second. So I save it here. I think in the end, is it this table? Yes. So basically what I am trying to get is to bring the results of the projection, get the evaluation information, and save it into an object with the extension rdata. After that, I need to get all the scores, all the values from the given object, right? Which looks like this, which is a table of our models. As a reference, each one of these lines, it's like a grid in the extent of the map that we're going to end up creating. Apologies. So here we can see that I have a lot of zeros. This can be because there's a section where we have virtually no information, or we might have certain maps with absolutely no information, right? I think we might have seen a couple of examples later on. Now that we have that, we need to prepare to create the map, the actual map. Well, not the actual map, but the table that refers to the actual map, right? And for that, what we need to have is the TSS information, the evaluation information that is getting here. Yeah. So B, hold on just a second. So B is okay. So here what I'm trying to do is to bring one of the columns, or in this case is one of the models, and we are going to create a weight for it. So we're going to create a weight based on a given TSS. In this case, it's going to be the TSS, which is significant, which is 0.99. So we're going to create once again a column for that given model with that weight. I hope I'm expressing this correctly. Pardon me if I don't recall exactly the appropriate words, but we are creating a weight model score, because that one so here, hold on. So this continues to be, so far this continues to be one of the multiple models that we were working with. And some. One second. Let me take a look. So yeah, so this is only a column, which is the extent of the whole map. And this is the average of all those values. So here I'm creating just, again, but just this is dedicated just to one model, the mean information. So let's say it this way, is for the GLM, this is the mean column. Yeah, so I ran 10 times GLM. So here we are just creating the sum of the averages. Yes, I think so. Yeah. Then the only thing that I need to do is to bring the sum of all the TSS. Yeah, so it's the sum of all the TSS, and that is going to be used as my parameter to divide and have, in the end, the average of all models based on the most reliable models that were produced. The reliability is determined by the TSS, and each one of the models, well, was each one of the runs, right? Hopefully this is not confusing. If it's confusing, please let me know, and I will try to address this in a further video properly. Yeah, because you remember that I'm doing this very raw right now, but still not necessarily an excuse. So once we have the average of the models, then we can actually save this into an object that is our actual map, which here I have MP. So I'm just going to change this, right? Right now you are looking at that because it's a time period that I last failed. Usually I need to be changing this part in each one of the runs. So here, boom, there you go. Yeah. So all these scores is one of the pixels in my extent of interest. Okay, so now we have all of that. So here comes the last step in the modeling process, which I will need to apologize once again, because I really wanted to run this, but this is what just happened. I managed to produce the maps, but now I can't. Somehow I'm getting some weird error, and I don't know exactly what changed between a couple of days ago and today. So if we want to do this very simple, like one by one, which is not recommended, especially back in the day when I had 94 species. But if for some reason the step by step here is just we create an empty map. No, we create a map like with the identifiers, the grid ID of our extent, and then we use the reference, the ASCII reference of our extent. And the last two steps, this is the one where I'm getting the mistake, is to acquire the values of the amphibian of interest, yeah, and then just write a raster with the extension ASCII. So basically it's just format, like prepare the full extent, and then just fill with the data that we were using previously, right? These guys. Now we can also do this in a loop, which is recommended. And it's basically the same, the last, what we just had a moment ago. So it's like bringing the object. In the last one, I need to be bringing that object like literally manually. So here I'm bringing the object of the given species of the given time, get the evaluation information, well, not the evaluation, the actual scores that we would produce in the proper order of the map, and finally save it into ASCII. So yeah, again, apologies because I really don't know what changed, because these processes is like very fast, and that's why I wanted to run it today, but I've been unable to do so. So now I will continue going. I'll continue here, and I will show you the maps. Yeah, I will show you the maps. So I already load them here. What? What's going on? What's going on? It's awkward. This is awkward. Oh my god. Give me just 1 second, guys. Let me pause. Okay, so I recovered the maps. So that was strange. So anyway, so here they are. This is technically what we will be working with for the prioritization. Just to give a little bit of an explanation, right? So the symbology that is using over here in black in grayscale, so the darkest places, it's where we have the least suitable areas for a given species, right? Let's do a very quick exercise here, which 1 second. So let's compare one of these maps with the records of the species. Okay, so where did I leave them? This, yes, okay, so allow me to just duplicate this guy. So let's go with Altamirani. Have 3 more minutes. Just make it bigger. All right. So these are the records that I have for that species. That. Boom. So I would expect that all the maps are like pretty restricted to that area. Let's see. So the one that I'm about to show is future under the worst case scenario. So 2023. So how does that look? Interesting. So while there are, so in here I would be losing most of the environmental conditions. But this is funny. I think this is Mexico City, where I would have the most suitable conditions. That would be the weirdest thing, yes? Huh. Okay. Okay. Let's go and check the one in terms of past information. So we continue having a lot of the best conditions in Mexico City. So this is actually very interesting and strange. For this kind of stuff, it's also recommended to know, which I don't know, the specific characteristics of this species, right? And finally, so this makes a little bit more sense, right? Only on the south, we have some weird results. Okay, so there are things that we can be keeping discussing over here. I'm gonna leave the video now over here, and what follows is preparing for the prioritization process. So yeah, so we'll keep it working over here, and until the next one. Bye bye.